For us, AI means that there's a recommendation produced. It's not just an insight, it's an action. And that action can be taken autonomously, or that action can be taken as a bit of advice that, let's say, an operator can either take or not take. But ultimately, AI is about the actions.
You're listening to Augmented Ops, where manufacturing meets innovation. We highlight the transformative ideas and technologies shaping the front lines of operations, helping you stay ahead of the curve in the rapidly evolving world of industrial tech. This week's episode is hosted by Rui Metres, Head of Ecosystem at Tulip, the Frontline Operations Platform.
Welcome back to Augmented Ops. Today we're joined by Erik Udstuen. Welcome to the show, Erik.
Thanks for having me.
So you've been in an industrial software space for quite some time, but why don't you introduce yourself for those in the audience who may not be familiar with your background?
Sure. I've been working in the industrial software space for 30 plus years. My background is as a chemical engineer, a process engineer. I started in the pulp and paper industry, and pretty early in my career implemented some, what at the time wasn't called AI, implemented neural network technology, and did some pretty interesting things very, very early in my career. And then also had an opportunity early in my career to start my first startup. So about 2 years out of university, started my first company, which really focused on doing advanced analytics for first in pulp and paper, but ultimately in many industries. And so fast forward to TwinThread. TwinThread's my fifth startup I've done, technology startup over the years. They've all been in one way or another focused on analytics. All but one was focused in the industrial software space. So I've been working in that space for a very long time.
That's awesome. Always a pleasure to speak with a serial entrepreneur. Is it true that before 2003, when I guess Tulip wasn't even exist, you actually kind of set the foundation for a use case agnostic MES or something like that? I don't know, maybe the foundation for frontline operation platforms.
Yeah, that's absolutely true. When we started our first company that ultimately built the Prophecy MES software, and the conventional wisdom at the time was that MES needed to be hyper industry specific. And there were good examples in the industry where, especially in like semiconductor, for example, where those vendors that built those specific industry solutions were the ones that were succeeding the most. But if you looked at the broader set of industries, they weren't getting what they needed as far as MES was concerned at that point in time. So we set out as part of Mountain Systems at the time to build an industry agnostic MES. Granted, it was focused on process industries for the most part, but we ended up serving a wide variety of industries. And I would say that the differentiator at the time, which is now pretty much industry standard, is integrating in with the automation and the historians and technology like that help to normalize those MES functions across many different industries. It's kind of like a normalizing buffer in between what the MES needed to do and all the variety and automation systems you found out there.
And today you're obviously at TwinThread. Can you kind of walk us to what is the need that you realized in the market? Probably, I guess the root for that can go probably 20 years back.
Yeah, I would say even 30 years. In my very first experience as an engineer working in a plant, implemented the neural network technology to predict breaks on a picker machine. So those of your listeners that are in the paper industry would know exactly what that was all about. And that was way before we even called it AI. If you fast forward 15 years in my career from that point, I found myself at General Electric running their industrial software business. And we were focused a lot on servicing large fleets of assets, things like gas turbines and aircraft engines. And particularly in the energy business around gas turbines, we did some very innovative things, applying analytics and applying machine learning. And again, before it was called AI, to predict catastrophic failures on equipment, as well as to improve efficiency on the equipment. And we did some groundbreaking stuff at that point in time. So I got a sense of what was possible at scale. And through that experience with GE, there was tremendous benefits generated from applying advanced analytics techniques to that large a fleet of assets. And I walked away from that experience believing that not just the power generation industry should have benefit of this scaled approach to analytics, and really set out to build TwinThread to address the needs of the other process manufacturers, things like consumer products, specialty chemicals, pulp and paper. These industries where they're not purely continuous, they have a mix of discrete, continuous process and a whole variety of manufacturing types under one roof that needed tools to do analytics at scale. And that was the need that we saw, and that's why we started the company.
So is it fair to say that at TwinThread, you're utilizing different technologies that hopefully we will discuss in a second to really tackle these predicting problems on your assets in kind of the most generic way of doing that?
Assets and processes. I think that's a very important thing, is the combination of asset optimization and process optimization. So yes, and being able to do that at scale is really the core of what we're doing.
So I'm super curious here, but when I trained my first AI model, I don't know, 10 years-ish, doing my master's in computer vision, back in the then, today, I think people think about AI in different ways. But back in the days, AI means you need a good data set of input and outputs, kind of, raw data and labels. In the basic computer vision, it was classifying images of dogs versus cats.
Right.
And then you get an image of a giraffe and you're kind of stuck because the model knows that, there are only cats and dogs in the world. But fast forward to today, what type of data are you using? How you collect that data? Are there limitations to the data that you can collect?
Well, I would say that the problem of data quality and having good data is still the same problem it was 10 years ago when you went through that exercise. I think the good news is that the technology to structure the data, cleanse the data, enrich the data have come a very, very long way. So in terms of the types of data that we're interested in to build these process optimization and asset optimization models, we're talking about things like all of the automated sensor data. We're talking about the offline quality test results. We're talking about what you might call traceability data, the flow of batches of product or lots of product moving from one part of the process to another. So quite varied in the types of data that are needed to drive the model. You're really aiming to capture the reality of what's actually happening on the plant floor in as high a resolution as you possibly can. And that involves manual processes, just as it involves automated processes. And you really need to cover the broadest set of that to have the most complete models and the best chance at achieving the results that you're looking for.
So I think we covered kind of the beginning of AI, at least from your position, but that's kind of only half of the story of TwinThread, because you're also using the digital twin to enhance the AI or combine these two technologies. Can you tell us kind of a bit more? How do you use the digital twin in practice?
Let's talk a little bit about the problem that we're trying to solve with the digital twin. And then maybe we can talk a little bit about the layers that I like to talk about of a digital twin, because there's multiple layers to it. In a sense, the problem we're trying to solve is one of standardization. If you go into a single plant even and look across two different production lines, you're going to see a high degree of variation in the data that's available, how that data was labeled or named, things like tag names. They followed a convention or they didn't follow a convention, different vintages of equipment. So just enormous variation that you find within the plant.
And that's even in a case of like two lines that produce the same product.
Two lines that produce the same product or same set of products or similar set of products. So like fundamentally, the function of the process is to produce the same thing, but the automation and all of the data can be quite varied. So in one way, you need to have a normalizing layer to be able to call this particular temperature measurement temperature instead of ABC 1, 2, 3 on one line and XYZ on the other line. So at its very core, The role of the digital twin is to normalize this data into a common structure so we can build a model once and apply it many, 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 many times because of that standardization that's occurred at that layer. Our largest customer has 450 sites, 650,000 assets that they're managing, and enormous variation in the automation, sensors, how everything is named and labeled. And the only way you achieve that kind of scale is to have that digital twin standardization layer.
So you're using the digital twin as more or less a data model in this case?
It is. Yeah, it is. That's one layer of it. As I mentioned earlier, we like to think of the digital twin as having 6 or 7 layers, depending on how you want to see the world. Part of the digital twin is the sensor data. That's one layer. Another layer of the digital twin is the visualization. I think many times that's all customers think about of a digital twin as being this 3-dimensional visual that you can explore. And that's just one layer of it.
Mm-hmm.
The next layer are things like we call digital threads, but you might call them digitized workflows, digitized work process. Another layer of the digital twin is alerts, alarms, and events. And so there are several layers to that digital twin. And the topmost layer is actually the AI models that run on top of that and produce recommendations about how to run the digital twin better. And we sort of view all of that as components and layers of the digital twin.
I think, many people, when they speak about digital transformation in a philosophical conversation, it's at the end of the day about taking data and convert it into insights or actionable insights even. That's basically what you're doing from A to Z, because you're starting from the data collection, modeling, and then the AI layer that actually give insights to the operator.
That's correct. And I would say it goes beyond insights. This gets to a philosophical question in the marketplace. It's obvious that everyone wants to stamp AI on everything possible. There's a lot of hype around it. But for us, AI means that there's a recommendation produced. It's not just an insight, it's an action. And that action can be taken autonomously, or that action can be taken as a bit of advice that, let's say, an operator can either take or not take. But ultimately, AI is about the actions.
I want to shift kind of to, one of the fundamental problems that we see all the time with customers, which is different standard of data, of protocols from MQTT through OPC UA, and, you name it, in the last 30 years of technology of standards. What is kind of your approach to that challenge and problem, and what you want to tell all the vendors in the world today?
Yeah, I think it's clear to us as relatively young companies that no single vendor can do everything. And, I would say it's less clear to the traditional automation vendors that's the case. So, in a way, we have some work to do. In the industrial automation space specifically, we've seen literally wave after wave of the latest hot trend in interoperability or connectivity. And this goes back pretty much 30 years. From where I sit, it looks like the movie is just playing over and over again. People are trying to solve the same problem again and again and again, and they're not solving it in any fundamentally different way. It's just recycling the same problem again and again. Now, with the cloud, it opens up a lot of new possibilities. And I would say that this ecosystem of young companies should be banding together to kind of lead this next wave of interoperability in a way that's fundamentally different than the previous waves. In a lot of ways, the previous waves of interoperability and standards were all about the data model. Like, if we can all agree on the data model, life would be great. And the reality is that our customers have an enormous amount of infrastructure out there that take 30 years to turn over that infrastructure. And rather than tell customers, please adopt this new hot standard, we ought to be thinking about how do we interoperate with what's there today and how we add value to it. So in my mind, what needs to be solved is not a data model problem. It's an application and a workflow problem. And I would say the sooner the young companies, the cloud native companies kind of band together around a way of interoperability of applications and workflows, that we will make progress much faster in the market together. And I'm not saying the interoperability and data standards are important, but it's not enough to turn over 30 plus years of infrastructure that's out there, that it has to work the way it works. And we need to deal with that.
So, a controversy question. So what should we do with ISO 95 then?
It's a very interesting question. Not on ISA 95, but on ISA 88, we see tremendous opportunities for batch automation processes. And in fact, the ISA 88 space and batch automation was sort of past its prime by the time that ISA 95 emerged. And so that market, it's been 20 plus years that any new value has been added on top of the S88 standard. And I would say that as far as ISA 95 is concerned, it's very similar to that. There's been a long period of time where there's been any new value created on top of the ISA 95 standard. And it's due for an upgrade, if you will, not to replace the standard or to redefine a standard, but rather have common applications and common workflows that work on top of, but aren't constrained by an S95 standard.
Okay, let's move back to the practical reality of the world versus the philosophical. So, I use TwinThread, the customer collects some data, do modeling maybe for the first machine. How you scale that into complete line, even like multi-sites, a full factory? You want to prevent problems in a full factory.
Yeah, I mean, it centers around the digital twin and that standardization that we talked about earlier. But on top of that, it starts with easy connectivity to all the different data sources that you have out there. So you have historians and SCADA systems and PLCs and DCS systems and instantaneous connectivity to those, I'll say, automation data sources. That is a critical element of scaling. If you're doing a project, you can't wait for a new thing to be created just to connect to data. That has to be an automatic thing. And move into the digital twin and having a strategy for standardizing the digital twin. And then beyond that, I think that the big element of scale is that getting the subject matter experts, the people that work in the plant or work in corporate, that have the domain expertise about the equipment and about the processes, enable those users, if you will, to build applications and do that in a no-code, low-code environment. That's how you achieve scale. If you're doing a transformation project and you're defining a spec and going through a big process and a big waterfall development, process, it takes way too long, and many of those projects won't get off the ground. And so the secret to scale is empowering the right developers. We talk about engineers as being developers. Maybe they don't think of themselves as developers, but if we can give them the right tools, the low-code, no-code tools to build applications and to innovate quickly, they are the developers that will move this forward fastest.
So you are basically referring to a citizen developer model, right? That's kind of a repetitive topic here in Augmented Ops. That's resonant with what many companies are doing today, which I think it's, this democratization of software, plus the fact that the people that are closest to the problem are actually the people that solve the problem, which is a lean principle.
Mm-hmm.
So take us through the day-to-day now of the factory using TwinThread. So you did the modeling, you have the data. How that impact the factory?
It centers around my earlier comments around recommendations. To be an AI solution, it means that the models are providing recommendations. So honestly, in an absolute ideal case, the day in the life of the operator doesn't change a lot just because they have AI enabling them. So what do I mean about that specifically? If an operator is used to using this HMI, this screen to run their process, our objective is to push the intelligence, push the recommendations into that same screen, so it's part of their workflow. as opposed to jumping to another system or jumping to another screen in order to receive some insights. So that integration of the recommendations into the workflow is critical to making the day in the life of the operator as efficient as it possibly can. How that literally happens if you're using TwinThread is, let's just say that you're running a process to produce a food product, and operators are responsible for quality as part of one of their key workflows. And so rather than going out and turning dials on flows, pressures, temperatures manually, they're supervising a model that's making those changes automatically. And the way they interact with that technology is through the same screens that they've been using potentially for decades. So that to us is sort of the ideal scenario.
I love that. So, we started with data. We talked about AI. We touch alerting and modeling and scale. At some point, we even talked about philosophical data modeling, but we end up back to, humans, the operators, the people that live the day-to-day in the shop floor. And that's the best way to bring value back to the business.
That's right.
Yeah, I like the concept. And recently, I was into the weeds kind of integrating Tulip into TwinThread because it's one of many, I guess, system of interfaces, like you mentioned, HMIs, and where the operator actually do their day-to-day. Does that mean that you're integrating with huge amount of screens and interfaces?
Yes. I will say that the legacy screens, if you want, the legacy SCADA systems, as one example, they have the benefit of being part of the current operator workflow, but they do have limitations. The opportunity we see, for example, the integration with Tulip is now that same process engineer that's optimizing the process using TwinThread and the TwinThread models can very easily build out the steps in the workflow and the operator environment that can upgrade the workflow, upgrade the work process to incorporate the recommendations coming from the AI.
Okay. We didn't touch generative AI, which is kind of, what's happening in the last year is, I'm sure someone is already writing a history book about this leap of technology. In your head, when you think about AI, it's fundamentally different, like the type of modeling that you're doing from the generative AI buzz that we see today, or these are similar beasts that are going to converge into a single AI mechanism?
If there's one single message that I would like customers and prospects to hear is that it takes considerably more to run a plant than generative AI, even as it's fully developed. So when we talk about AI, industrial AI, let's call it, it's a superset of which Gen AI is a subcomponent. There's some exciting cases for Gen AI. I've been saying for a couple of years, that's not enough to run a plant effectively. It actually takes all kinds of different AI, different models, different AI technologies. And at the same time, we can't overlook the simple cases of just first principle models without the fancy AI. There's value in all of that as the full superset. And I think the market is overly focused on Gen AI. Don't get me wrong, there's some very exciting use cases, but it can be some time before they fully develop. And even when they fully develop, you need to be thinking about running your plant with multiple flavors of AI, not just generative AI.
So last question before we're wrapping up. I want to go back to the fact that you founded 5 companies. What's your one unique tip that you want to give young entrepreneur that is now thinking about funding a company in manufacturing?
I think that what's driving the world today, this may sound a little bit funny, it's clarity in the business case. It used to be that you could found a company and maybe not have so much clarity in the business case or the business model or what the value was for a customer. And I think that those days are perhaps over. And my advice to an entrepreneur starting up today is just have hyper clarity on the specific problem that you're solving. What pain are you solving? And what economic value does solving that pain deliver? I mean, it sounds basic, especially us that come from engineering and a technical background. We do tend to like to solve problems that are hard, and we get a lot of intellectual stimulation out of solving hard problems. However, If you want to build a viable business and make an impact on the world, you absolutely need to be hyper-focused on the pain point and the value of solving that pain point.
I like that. Start with why. This was super insightful. Thank you for joining the show, Erik.
Yeah, excellent. Thank you very much. It was a pleasure.
Thank you for listening to the Augmented Ops podcast from Tulip Interfaces. We hope you found this week's episode informative and inspiring. You can find the show on LinkedIn and YouTube or at tulip.co/podcast. If you enjoyed this episode, please leave us a rating or review on iTunes or wherever you listen to your podcasts. Until next time.